video, I just want to do a review of solving linear equations. Let's start with something that's really pretty basic. Suppose we have an equation that looks like a plus 2b equals 12. And the directions say that we are to solve for a. If we want to solve for a, then the thing that we need to get all by itself is this a right here. The way you get it by itself, first of all, you'll notice nothing's multiplying a. So we don't have to worry about dividing anything, but you generally don't divide first anyway. We want to get this 2b off this side. So we would say minus 2b minus 2b. When we total this up, remember, think of this as being both equal sides of a scale. This side would just be a plus 2b minus 2b. This side, of course, would just be 12 minus 2b. So when we solve for a, we get that a is equal to 12 minus 2b. So nothing very complicated about that. Suppose instead we have the same expression. Whoops. We'll just kind of draw a line under it. And we start with a plus 2b equals 12. And this time they ask us to please solve for b. That means we want to get this b all by itself. Notice it's being multiplied by 2, but even more importantly, we've got this a over here, so we're going to subtract the a first. Again, think of this as being a balanced scale. Both sides are equal. As long as we do the same thing to both sides stay equal. A plus 2b minus a, those are going to go away. We get 2b equals 12 minus a. So to finish solving, I don't want to know what 2b equals. I want to know what just 1 is. I'm going to need to divide this by 2. So I have to divide this by 2. The result, of course, is that I'm going to get that b is equal to 12 minus a divided by 2. I can leave it exactly like that. B is equal to 12 minus a divided by 2. If I want, I can go ahead and divide by 2. 12 divided by 2 would be 6. Remember, this is 1a. 1 divided by 2 is 0.5a. I really like this answer better, 12 minus a over 2, but some people might prefer this answer. And if you were doing a multiple choice, you'd want to be able to solve it either way. These are called literal equations because we don't actually get a number. We're just solving for an expression. If we have something like this, y is equal to negative 2 over 3x minus 1, and we're asked to solve for x. Now, one of the things that makes this trickier is the fact that the x is on the bottom. Anytime I have an equation and one half looks like a fraction and the other half does not look like a fraction, one option is to put this over 1. Y divided by 1 is still just y. But if I do that, I now can solve it rather like a proportion. I can say, hey, you know what? Let's multiply this together and let's multiply this together. 1 times negative 2 is going to be negative 2. Y times 3x minus 1. Notice we are going to have to do some distributive multiplication. That's going to be negative 2. Y times 3x is 3xy. Y times negative 1 is minus y. That doesn't look like a fraction anymore. What are we trying to solve for? We want to solve for this x right here. So we do that same kind of thinking. This is a balanced scale. These two sides are equal. What should I do first? I want to get this by itself. So the first thing we do is do plus y. When I do plus y, this is going to become negative 2 plus y, or y minus 2, either way. Negative 2 plus y. On this side, 3xy minus y plus y. Well, minus y plus y is just 0. This side is just going to equal 3xy. Now, I'm trying to get x alone, and we can do this in one step or two. I prefer one. I need to get rid of the 3y. 3 and y are both multiplying, so I divide. Okay. That cancels, and that cancels. So I end up that this side is just x. This side is negative 2 plus y over 3y. Or negative 2 plus y could be written as y minus 2 over 3y. Those are both exactly the same thing. I just want you to see how it might look different. Now, some of the time when we're solving these equations, we do want to actually get to a number. Let's consider a linear equation that looks like this. 12.4 is equal to 3w plus 8 minus 0.5w. Usually when you have an equation like this, if both w's are on the same side, we can simplify this. We can add this w and this together. So this will be 12.4 equals 3w minus 0.5. So what is 3.0 minus 0.5? That is going to be 2.5. So if I have 3 w's and I take away a half a w, I end up with 2.5 w plus 8. Now this is looking more like what we did earlier. I want that. Here's my little imaginary line that says both sides have to stay equal. Drawing that line will help you remember where you are. So, minus 8, minus 8. 12.4 minus 8. You got a calculator if you need one. It's going to be 4.4. 2.5w plus 8 minus 8 is just 2.5w. Okay? So our next step, of course, will be to try to get the w completely alone. We're going to divide by 2.5 and divide by 2.5. So now we need that calculator. 4.4 divided by 2.5 is 1.76. So now let's do it in black. 1.76 is equal to w, and that would be your solution to that equation. Let's do one more ugly one. It's almost time for class, so I need to finish this up. But I want to do one more. One that's a little harder looking. 53 equal 8 plus no, I'm not liking that example. I'm going to skip that one. Let's do 3, so our last one, 3 equal 18 plus n over 44. Again, if we want to, we can make this look like a proportion. When I do that and I cross multiply, I get 1 times 18 plus n equals 3 times 44. This will actually be very easy. So I have 18 plus n. 3 times 44 is going to be 132. I'm just solving for n. So I say minus 18, n is equal to 132 minus 18 is 114. If you're not sure, plug it in and check. If I have this equation, I can just plug it in. 18 plus 114 divided by 44. I get a calculator. 18 plus 114 is 132. And if I divide that, I get 3. Well, this side was already 3. So that's proof we found the correct answer. I'm going to stop right here because it's time for class. They're going to wonder where I am.